Make this thing go. There we go. So on this one, what's going to go in for, I guess we got 3.14 times, and we got big D as our first number. What's going to go in for big D? 12. Good. What's going for little d? 5. And of course for x, 23. So now I'm going to take a little bit of liberties with my order of operations. I'm going to do a couple of things at once here. I can do that multiplication to get 6. I'm going to do that multiplication as well. Technically, that's the next step, but I can do it all at once here. Gives me 2.5. And I'll do that multiplication as 46. Six minus 2.5 is 3.5. Then I'm going to have to multiply here 3.14 times 3.5. Then let's go ahead and add the 46 to it while we're at it. 56.99 inches. So that would probably be considered a 57-inch belt. Now there's a lot of slop in that formula there. The one big thing it did not correct for is the fact that this goes at an angle here. That's going to add some length to it. There are other formulas we're going to run into over the next several weeks that are more complex than that one. Just so you're aware. I'm talking like next week. Just so you're aware. We probably will be, maybe not by next Friday, but early in the week after that at the very latest, looking at our next unit test. Because then what I usually do is the last couple of weeks we do stuff that's nice to know, but not something I want to test you on. I may quiz you on it, but I won't test you on it. Like going into 3 variables instead of just 2 and stuff like that. Now we're going to look at a taper pin here. We're going to have a large radius and a small radius, just like having a large diameter and small diameter. You'll see why we're doing radius here in just a second. H is the length of it. What we're trying to find is this sloped surface, slanted surface. I'm going to call it S. It's like the slant height of our triangle, of our cones and pyramids and stuff. That length S, if we think about it, it's from a right triangle here, isn't it? What's the length of the bottom of this right triangle? H. What's the length here? Careful, it doesn't go all the way down. I drew it kind of poorly. It's big R minus little r, right? Because if I'm looking at it here, right, it's the difference between this and this. So S squared would be H squared plus, oops, the difference in my radii squared. The way we typically write that formula is rather than having S squared, we have S equals the square root of H squared plus big R minus little r squared. So if I give you a taper pin and I tell you that this is 48 millimeters and this is 28 millimeters and this is 35 millimeters. Find S for me in your notes. Okay, so what goes in for H? 35. Now here's where you got to be careful what goes in for big R. 24, because that's the diameter. You know the radius, have to cut it in half. Minus 14. Yeah, you got to be very careful that what you're reading off the print is what they need. So of course, we subtract that to get 10. Well, 35 squared is 1,225. 10 squared is 100. Yes, it's going to be the square root of 1325. 36.4 millimeters that would be in. Well, throwing inches on there though without doing a conversion is kind of sloppy. Now, one of the things we can do with these is we can solve them for one variable or other. For example, back to our pulley, or pulleys, I should say. We had that formula, the length of the belt equals pi times 0.5 big D plus 0.5 little d, then plus 2x. There are a lot simpler ways of expressing that formula than the way it's written right there. But I chose that form because what if, without putting any numbers in there, I want to solve it for big D? To do that, first I would want to multiply the 3.14 through. I got to distribute that, right? So 3.14 times 0.5 D, well, 3.14 times 0.5 is 1.57 D, of course. 3.14 times 0.5 little d, well, 3.14 times 0.5 is still 1.57 little d. So I've used the parentheses, they're gone, plus 2x. Now I am solving for big D here. That's my variable. Big D has been multiplied by 1.57. This other stuff's been added to it, right? So to take it apart, I have to subtract first and then divide. So I'm going to start by subtracting both of those pieces. They've both been added, so I can subtract them both. I got here, nope, that should be plus. Yep. I had subtract up there. It shouldn't have been. I screwed up there. We won't go back and change it now, but it should be plus. It should be plus up there. That was my fault. I'll take the blame. I won't even try to blame the pen that the pen made it disappear. I'll take the blame on that. I probably wrote it down wrong. It's early in the morning and I'm totally sober. Not a good combo. So over here we've got L minus 1.57 little d minus 2x. So we've subtracted all those. All that's left on the right side is 1.57 big D. So now to get, now that one is the pen's fault. So now to get big D by itself, we need to divide by 1.57, right? Remember, when we divide, we have to divide every digit. So over here, every digit has to be divided by 1.57. So L divided by 1.57 is L over 1.57. Negative 1.57D divided by 1.57 is just negative D. And then minus 2x over 1.57 equals big D. Why would I want to do this? Well, that's just a bonus. If I'm looking to solve this, if I've got a pulley system and I have two shafts that are a certain distance apart. That's my X. And I know one of the pulleys is a certain size. That's my little d. And I know I have belts that are a certain length. This would allow me to calculate how big of a pulley do I have to put on this other shaft to make that belt work. Well, it all depends on what you're doing. If the RPMs, if the rate is important, the speed is important, yes. If you're looking at just a conveyor where speed isn't important, and you're looking for a quick fix, there's a lot of different applications. Or there may be places where I could do it the other way. Rather than solving for D, maybe it'd make more sense to solve for X. Because now I know what pulleys I need. I know what size pulleys I need because the RPMs have to match up. I know what size belt I have to go around them. I need to know then how far apart am I going to set the centers of those pulleys so that they work, so that belt works. So the same thing would happen here. Now here, if I'm solving for X, I could multiply this out if I wanted to. And I would still get the 1.57 big D, 1.57 little d plus 2x. Then I would still have to subtract both of these. Now I'm subtracting these this time instead of the x. I'll subtract them from over here as well. So what I would get is L minus 1.57 big D minus 1.57 little d equals 2x. This time I would be dividing by 2. Now if I wanted to, I could divide each piece out, do L over 2, and 1.57 is what, 0.785 or whatever divided by 2. I could do that, or I could just leave it like this. It's not a whole lot. It all depends on what form you feel is easier for you to work with. Solving it for x, there is no exact one way. I could leave it like this, or I could make it L over 2 minus 0.785 big D minus 0.785 little d. Those are equivalent. But which one is easier for you to work with? If I could get paid to work with those. Still got a hard mount in the main mount. The flat only has so much adjustment. Okay. So let's say we have a formula like S equals the square root of D squared over 4 plus H squared. And I want to solve this for D. So what I'm trying to do is get D here all by itself. What's been done to D here? Well, first it's been squared, right? Then it's been divided by 4. H squared has been added to it, and then finally square rooted. Everybody see what we're saying over here? If D were a number, the first thing I'd have to do is square it. Then I'd take that result divided by 4. Then I would add the H squared to it, and then I'd square root the whole amount. So now to solve this, to get D by itself, I got to reverse that. How do I get rid of a square root? I square it. The square root and the squared cancel out. So the square root symbol is gone now. On the other side, S squared becomes just S squared. Next piece I have to get rid of is adding the H squared. Do I do that by subtracting H squared? So now over here I have s squared minus h squared equals, that's gone. This is just d squared over 4. Next thing I get rid of is, I have to multiply by 4 to get rid of that. Perfect. So over here I'm going to multiply by 4, right? So those fours cancel out. That's just d squared. I'm going to distribute the 4 here. This will be 4s squared minus 4h squared. And then finally, getting rid of squaring it by square rooting it. So that cancels out the squared there. That's just d. D is equal to the square root of 4s squared minus 4h squared. What do you think? You don't have to square root the 4 and make it a 2. Well, because when I'm square rooting it, I'm square rooting the result of this. So I can't square root the s separately because I've got to combine it with the 4 and then the negative 4h squared yet before I can square root it. All of this here has to happen first before the square root. So I'm not changing that power, that square root. Over here, the square root and the squared cancel out because that's all it was d squared, right? If this were 4s minus 4h squared, now that whole thing is squared, right? If I square root it, then that would cancel out and just be 4s minus 4h. But here the squared is on each individual piece, not on the whole thing. It is tough because you just got to think of what has to happen first here. Once I put that square root symbol around that, the s here has to be squared first and then multiplied by 4 before it gets to that square root symbol. And technically it has to be combined with the negative 4h squared first too. And that's exactly it. That whole side over here, go back to the green here. That all exists before we come in and apply the square root. Here, the square root and the squared are all operating on just one thing, so they can cancel out. Here, the squared only operates on the s, the square root operates on the whole thing, so they're not canceling each other out. They're not operating on the same thing. This squared only operates on the h, the square root operates on the whole thing. Over here, the squared operates on the d and the square root operates on the d. They're both operating on the d, so they cancel out. Oh yeah, it's not simple stuff by any means. Okay, how many of you managed to finish all the problems in that packet? I didn't think so. What do you have? That's fine. Let's take a look at it. 26. Let me get to it here. Okay. So oops, get out of there. Number 26. This would be on page 221. We have 14 times the square root of x equals 6 times the square root of x plus 8 plus 16. Well, we see parentheses. Parentheses always scream at us. Do something here first. So the 14 times the square root of x over here is not going to change. We've got 6 times the square root of x, which is just 6 times the square root of x. Yep, 6 times 8 is 48. So now I can combine the 48 and 16 over here to make 64. Now, if this were 14x equals 6x plus 64, what would I do there? I would subtract 6x. I'm going to do the same thing here. I'm going to subtract the 6 square root of x. 14 minus 6 is 8, so 8 times the square root of x equals 64. Now from here, I've just got to get x by itself. I'm going to divide by the 8. Square root of x equals 8. And then finally, square it. The root and the squared cancel out, gives me x. 8 squared is 64. So 21? No, that's okay. So as we look at this one again, we're trying to get b by itself. B has been what's been done to B. It's been divided by 2, power of 3, and 34 has been added, right? So to reverse that, we subtract 34. So I still got b over 2 cubed equals 8. And then we undo the power of 3 gets reversed by a third root. So those cancel out. I got b over 2. The third root of 8 is 2. And then dividing by 2, we get rid of by multiplying by 2. B equals 4. And what was the other one you said? 27. Number 27, 8.12 p squared plus 6.83 p plus 5.05 equals 16.7 p squared plus 6.83 p. Now, like we said, we've got p squared and we've got p. Having the variable and the variable squared, having a variable with 2 different powers makes solving these equations very, very difficult. We'd have to use methods that we don't know how to use yet. So in order for us to solve this, we've got to start combining things and hope that either the p squared, which would be the most convenient, right, if the p squared disappeared, or the p disappears. So we've got a p squared on each side. We got to get rid of one. The smaller one is 8.12, so we subtract it. So on the left side, we've got 6.83p plus 5.05 equals over here. We subtract, that's 8.58 p squared plus 6.83 p. Now we've noticed there's a p on each side. Subtract the smallest one. They both happen to be the same, so that disappears. So one of them did disappear. We're left with 5.05 equals 8.58 p squared. So now to solve for p squared, we have to divide by the 8.58. This is probably going to turn out to be an ugly number. Gives us 0.5886 equals p squared. And then, of course, our last step, square root it. So that cancels out the squared there. We square root this mess. 0.767 we'll go with. Equals p. Loads of fun, right? Well, we're enjoying ourselves here. Let's look at number 30. We've got 2y cubed minus 2.80 times 5.89 plus 3y equals negative 23.87 minus 8.40y. First thing we see here is parentheses. Parentheses scream, do something here first. 2y cubed. Well, 2y, there's nothing to do inside it. Cubed, what's 2 cubed? 8y cubed is y cubed. Second set of parentheses here is being multiplied by the negative 2.8. Distribute that. Negative 2.8 times 5.89. 16.492. It's a negative. Negative 2.8 times positive 3y is a negative 8.40y. Equals, this is a negative 23.87, negative 8.40y. Now I see that there's a y on both sides. I'm going to get rid of one of them. And I also notice it's the same number, so when I add, it just goes away. So now I've got 8y cubed minus 16.492 equals a negative 23.87. Now we've got to get y by itself, so we're going to have to add the 16.492. So that's gone. 8y to the third equals, let's see, we get 7.378. Does that look right? Negative 23.87 plus 16.49. Negative 7.387. Negative. I forgot the negative. There we go. So it's negative. And then, of course, we have to next divide by 8. So y to the third equals negative 0.9225, right? Just because it's early in the morning, I want to make sure. Yes, it is, right? Now, to get rid of the third power, we need to third root, right? So on my calculator, it's 3 math x root answer. Now, since it's negative, if it were an even root, I wouldn't be able to do it, would I? But it's an odd root. It's a third root, so I can do it. So y is 0.9734. Negative point. We'll go 973 is probably consistent with the decimals in the problem. What do you think? Good question. When we do a root, how can the number get bigger? Well, let's start out with squaring something, right? When we square something, it gets bigger, right? If I square 4, 4 squared is 16. If I cut that in half, I got 2. 2 squared is 4. If I cut the number in half, the square got cut by 4, right? Divided by 4. If I divide that by 2 to get 1, 1 squared is 1, right? If I cut that in half again, I've got to cut this by 4. 0.5 squared is 0.25. Notice, went from 0.5 to 0.25. I squared something and it got smaller. The reason is we went on the other side of 1. If things are larger than 1, when we square them, they get bigger. When we square root them, they get smaller. But when things are smaller than 1, when we square them, they get smaller. So to square root them, they have to go the other direction. They have to get bigger. Now, it is kind of weird because we're so used to square root something and get smaller. But if it's like 0.2 and we square root it, it's going to get significantly larger. Yeah, good question. So what I want you to work on for tomorrow, in that packet, still page 221 through 224. Work on those problems. Some of them are rearranging. Some of them are a little different than what we went over today. They actually give you numbers to put in there and solve for a certain variable. Like I said, I think these formulas in here are probably the most useful ones we're going to have for this semester. These are all right out of the machine.